Section 7.6, Example 4 on page 557, we have natural logarithms are useful because they help express many relationships in the physical world. Example 4 says a spacecraft can attain a stable orbit 300 kilometers above Earth if it reaches a velocity of 7.7 kilometers per second. The formula for a rocket's maximum velocity v in kilometers per second is v equals negative 0.0098 t plus c times the natural log of r. The booster rocket fires for t seconds, and the velocity of the exhaust is c kilometers per second. The ratio of the mass of the rocket filled with fuel to its mass without fuel is r. Suppose the rocket shown in the photo has a mass ratio of 25. A firing time of 100 seconds, and an exhaust velocity as shown. Can the spacecraft attain a stable orbit 300 kilometers above Earth? The given information is that R is going to be 25 for the mass ratio, C is going to be 2.8 for the exhaust velocity, and the time is going to be 100. We are given the formula v equals negative 0.0098 t plus c times the natural log of r. When we plug in the information given, we have v equals negative 0.0098 times 100 plus 2.8 times the natural logarithm of 25. Multiplying negative 0.0098 by 100 gives us negative 0.98, and then when we plug natural log of 25 into a calculator, we get about 3.219. If we multiply and add this all together, we get v is about 8. So the maximum velocity of 8.0 kilometers per second is greater than the 7.7 kilometers per second needed for a stable orbit. Therefore, the spacecraft can attain a stable orbit 300 kilometers above Earth. The work for this problem is written out on the next slide. And now I would like you to try number 7. For exercises 7 and 8, use v equals negative 0.0098 t plus c times the natural log of r, where v is the velocity of the rocket, t is the firing time, c is the velocity of the exhaust, and r is the ratio of the mass of the rocket filled with fuel to the mass of the rocket without fuel. See problem 4 that we just did. Find the velocity of a spacecraft whose booster rocket has a mass ratio of 20, an exhaust velocity of 2.7 kilometers per second, and a firing time of 30 seconds. Can the spacecraft achieve a stable orbit 300 kilometers above Earth?